All right, let's take a look at an example of compound interest where we're looking for how long it takes for a deposit to grow to a certain amount. In this case, we have a $5,300 deposit at 5.7% compounded monthly. About how long will it take our balance to increase to 9,400? All right, first off, it says the word deposited, but it does not say deposited monthly, yearly, quarterly, etc. It just says deposited, and so this is a lump sum. So we have our lump sum formula to the right. Okay, as we're reading through this, we have two values of money, and those will go in the two spots where money values go. The P of 0 is the initial value, and the P of t is after time t has passed. This is a savings account, so the smaller value will be the initial value, and the later value will be the larger value. So let's see, we will have P of t, so that's 9,400, equals P of 0, 5,300, and we have a parenthesis and a 1 plus. Now the R, we know we take the interest rate and change the percent into a physical divide by 100, and that gives us 0.057. So that's our R. Divide by, now the N value depends on what the compounding is. So our N value, it says compounded monthly, so that gives us N equals 12. All right, so we put in 12 for N up there as well, and then T is our variable. Okay, so we want to solve this equation for T. Now the issue with solving for T is up in the exponent, and in the exponent is difficult to access. We've seen problems where we need to find the rate and we use a root, but a root won't allow us to find the exponent t. But the first step is the same. We divide by the coefficient, and we can also reduce a couple of zeros out of that fraction just to make it easier to write, but I'm not going to go any further with the reduction. So we have 94 divided by 53 equals, and then we have parenthesis, 1 plus. Now I doubt the 0.057 divided by 12 plus 1 is a nice decimal, so I'm not even going to ask my calculator to calculate it, because then I have this ugly expression that I will want to round, and I should not round until the last step. Here goes the unusual step. To solve for t, we use what's called a logarithm, or log, on both sides, and it allows us to bring the exponent down in front of the log where it turns into a coefficient or a factor. So we now have log of the fraction 94 over 53, or you could still have 9,400 over 5,300. And then we can bring the 12t out in front of the log of all that mess, the 1 plus 0.057 over 12. Now what we're trying to solve for is t. T is now a product with 12 and this log. This, by the way, this is just one big ugly number. So it's just 12 times t times this ugly number. So to solve for t, we just need to divide by, oops, one little crazy there. There we go. Divide by the 12 to get rid of the 12, and divide by the log of the ugly number. To get rid of the ugly number. And you have to do the same thing on the right as on the left to keep this equation in balance. I think it's about time to update my computer. This thing is moving slowly. Still kind of working. There we go. Perfect. So on the right side, the 12 reduces, the log reduces. We went up with just t equals, and we have kind of a mess on the left side. It's a fraction. On the top is log of 94 divided by 53. And on the bottom is 12 and the log of that mess. Okay, now we go to our calculator. We're going to use our calculator to get the approximate answer. What we have right now is the exact answer. We're asked to round to the nearest tenth of a year. All right, let's take a look. So utilizing the mode, the math print on this calculator, we can do a fraction. On the top, the LOG button is right there. And then inside is a fraction, 94 over 53, parenthesis. On the bottom, we have a 12, and we also have a log of 1 plus and a fraction, 0.05057 over 12. You can verify visually that that's exactly what is written down. So when we hit enter, we have the approximation. We're asked to round to the nearest tenth, so the 10.07 would round up to 10.1 years. Okay, now we could check this with our original expression. Let me highlight the part in a different color. How about green? All of this is the compounding interest formula growing 5,300 for an unknown time. Now that we have an approximation for the time, we could actually use the exact time. We could ask if we grow 5,300 at 5.7% compounded monthly to the 12 times, and I'm going to use the answer button so I can use the entire 10.0765, etc. This should get us $9,400. This is the correct time. Now you might wonder how we can work this value out without that mode, because your calculator might not have it. Without it, going back to this expression, we have to make sure that we have a parenthesis around the denominator so that that operation, that multiplication, happens all inside the denominator. So that would be the extra parenthesis that we would need to add to make sure that it wasn't just the 12 that is divided, but the entire denominator. So that would look like log of 94 divided by 53 parenthesis divided by parenthesis, this is the denominator parenthesis, 12 times log 1 plus 0.057 divided by 12, close log parenthesis, close denominator parenthesis. That would be the keystrokes if you did not use or have the math print mode. All right, now it is your turn. Go ahead and pause the video, work this problem out on the right, and see what you come up with. Right, you should come up with 10.9 years. Well, this would be t is approximately 10.9 years. And you can check that and make sure you're right. Okay, I hope this helps.